Okay, so we talked in our prior video about how as the compounding periods become more and more frequent, then you're actually going to earn more and more interest on an investment like that. So what if the compounding periods become shorter and shorter? So we've got all the way down to daily. What if it was every hour, minute, or second? M would be getting larger and larger. It says if you consider the time period to be so short that it's essentially an instant in time, then you have what you call continuous compounding. And this is a thing. So if it's literally thought to be compounding instantly, then it would be continuous. So we have a continuous compound interest formula, which is A equals P e to the RT power, where E is the irrational number. So there is an E button on your calculator. If you look down here, there's an E to the X. It's under the second command, but that's what you'll use for this. So let's back up and do this same problem that we had just done where we invested $1,000 for 6 years at 8.5%, and we saw it go up and up and up. So what we should see, or what we should expect, is that if we do this continuously, we should get even a little bit more than this daily compounding. So we would find the accumulated amount of $1,000. That's our principal still. 6 years is our time. 0.085 is still our rate. The only difference is now we're using E here for our continuously compounded. And so then the power is the R, so the 0.085 times 6 power. The nice thing, I'm going to go straight to my calculator for this, because the nice thing about the E is when you call up E, so when you do the second and you hit E, it automatically puts you with an exponent, because really all you do with E's is take them to powers. So I can do 0.085 times 6 up in that exponent and hit enter. And we get $1,665.29 to the nearest cent. So they're almost the same. They're very, very slightly different. It was 10 cents more. So not a huge difference there, but it did follow the pattern of that's the best you can do for that situation. Continuous, there's nothing more often than continuous. So this is the very best situation. Okay, so one other thing that they might set you up with, we've got $1,000 being invested. So we know our p-value is 1,000 into some account compounded monthly. So that's our M value is 12. That's how often it's compounded. At the end of 30 years, so time 30, the account has a balance of $3,313. So that's the final balance. What is the interest rate of this account? So what's the R? Okay, so if I set my equation up here, then it would be that 3313 equals P, which is 1,000, times 1 plus the rate, which we don't know, over compounding 12 times to the 12 times, sorry about that, I'm getting a spam call, 12 times 30 in the exponent. Okay, 12 times 30 is 360. I'm going to remind myself of that because that's going to make this a lot easier. So we are trying to solve for R. There's a lot to be done here to solve for R, but it's all steps that you are well able to take. The first thing we would want to do is divide off that 1,000 from the front. So you just have to make sure you do everything in the proper order. Like you got to go again from the outside in. So we can divide off this 1,000. All dividing by 1,000 does is move our decimal point. So we would have 3.313 equaling the quantity 1 plus R over 12 to the 360 power. Now, in order to get that 360 power out of there, this is something you have to think back to your college algebra class for. You have to take the 360th root of both sides. As crazy as that may sound, we have to take the 360th root in order to cancel those out, leaving us with just 1 plus R over 12. In order to do a root on your calculator, you're going to want to go to the math feature, and notice number 5 is an X root. So I'm going to choose sorry, here, I need to quit. Let me go back out. You have to be planning ahead, which I just almost didn't do. You have to type in what root you're going to do first. So I'm going to do the 360th root. Now if I go under math and choose number 5, notice it puts whatever I had typed in as the root, and then I can type in what I want under that. So you do have to be planning ahead. So I can take the 360th root of this number and get 1.0033332914. And that's probably keeps going forever, and that's just however many decimal points I'm seeing. So your best option at this point is not to clear that out of your calculator. Keep it in your calculator and do a running tally here. So I know the next thing I need to do is subtract 1. Okay, so obviously that leaves me with just that decimal point part. And I'm going to write this down just so that you can keep track of what's going on. But again, I'm not taking this part out of my calculator. And then the last thing to solve for r is to multiply by 12. So if we multiply both sides by 12, we get 0.039994973. They will tell you how to round on something like this. If I actually make this a percentage, it would be like 3.999%. They'll probably ask you to round that to something like 4%. And again, check for logicalness and reasonableness there, because this is a percentage. If you're getting thousands of percents, you've probably done something wrong. You should get something, small, something below 10, I would say, as a reasonable answer there. It is easier to have your equation solved for whatever variable you are asked to find, if that's possible. So I'm providing you with formulas where so far we've had the formula set up as A equals. That's easier to use if I'm trying to find the accumulated amount. If I'm trying to find that future value, it's easier to do that if I can just plug everything in on the right-hand side and solve for A. So what if you're trying to find P? Well, there's nothing against, I'm going way back up here, there's nothing against using this formula, subbing in values here and over here, and then solving for P. There's nothing wrong with that. I just happen to think it's easier if all this equation here has been done is it has already been rearranged. It's the same equation, just rearranged and solved for P. I think it's easier to use this to find P when necessary, instead of doing the solving in the original equation. So I prefer to use this. Again, you do not have to use this formula to get the correct answer, but I do think it's easier. It keeps you from having to divide by something complicated during your solving, because the division was basically already done preemptively. Okay, so that is just kind of Carrie's tip. These are the formula choices I'm going to give you. So I invite you to try to do that when applicable.